Hey, what is good, everybody? Welcome back to the channel. In today's video, we are not going to set up our vertex and index buffers, but rather I have something really special for you guys. Today, we are finally going to draw our very first primitive, right? And that primitive is just going to be a nice little cool quad. So we are going to draw a quad in today's video. This is a quad, by the way. So what is a quad? It's just a square or it's just a shape that is made up of two triangles. Okay, so that essentially just form a quad. So we have the first triangle on this side and the other triangle on this side, and together, glued together by this line here, we basically have a quad. So this is what we're going to do in today's video. Now this will be possible because we've set up our command buffers, because our command buffers is what is going to allow us to be able to command Vulkan to essentially draw a primitive to the screen. So in order for us to draw this quad, there are quite a few things that we need to set up, quite a lot of things that we need to set up. So in this video, this is what I'm going to try and show you guys how to set up and how to get right, because we are using what we call dynamic rendering. So things are a little bit different if you're not using dynamic rendering in Vulkan. So we are using dynamic rendering, and dynamic rendering is only supported from Vulkan 1.3. Vulkan 1.3, I guess. So that is what's possible with that version of Vulkan, from that version of Vulkan. So this is the feature that we're going to be using to essentially draw our primitives. We're going to draw them using the dynamic rendering feature, meaning that we don't need frame buffers and all those other stuff that we used to need way back before this version. So so if you guys have been following along with the series, you'll know that we did set up some stuff to work with dynamic rendering. If you haven't followed along, I would suggest that you step back and just go back a few videos and just set up and then come back here so that things can run smoothly for you. So without talking too much, let's get some work done. So let's open up our rendered.h, and we're going to create some API functions. Right, so I'm going to put a comment here, and then I'm just going to be like API. So this is going to be our API, the way that we want to basically use Vulkan from the engine side, right? So these functions will be basically public, right? In the future, we're going to set up something called a GAPI macro, and then we have something like void Vulkan frame prepare, and then this is API. So what this GAPI is essentially is just a macro that essentially exports this function, because this renderer right now is not really a library, but we will turn it to a library, and then later on we can basically, you know, turn certain functions to make certain functions public so that we can access them from external applications, right? Etc. So but we're not at that level, and I'm not really gonna deal with that anytime soon in the series, and I might just do that on my own project rather than through the series, because it will be quite a lot of work, but there is that possibility, right? But anyway, this is the API that we're going to be using. So first function that we're going to have is a Vulkan frame prepare. This function will essentially just prepare the frame for rendering, right? So it will just prepare for us. It will just prepare the necessary things that we need to essentially render, right? It will acquire the next image, it will do this, it will do that, and then from there we're going to have another function that says Vulkan begin rendering, right? So once we've acquired our next image and all of that stuff that are necessary for us to begin rendering, we'll then call this function called begin rendering, and then this begin rendering function will have a friend called end rendering. So we'll have begin and end, and then we're also gonna have another function called Vulkan. Let's do frame submit. Okay, this one will basically submit the frame. Okay, and then after submitting, we can essentially present, right, to the screen. Okay, but before all of this can actually happen, I think it's best I actually include these functions first. I'm gonna call these Vulkan frame, I don't know, command list begin, something like this, right? And then command list end. Remember, we set up a command buffers, right? Now anytime we want to tell Vulkan to do anything or command Vulkan to do anything, we essentially need to begin a command and then end that command. So in terms of rendering, what we're going to do is we're going to begin a command buffer, and then we're going to prepare the frame, and then we're going to begin rendering, and then in between begin rendering and end rendering, we are basically going to do something like I don't know, Vulkan draw, right? This will then, you know, draw whatever it is that we want to draw, right? So this is how things are going to work, right? This is the order in which things are going to work. Okay, but then you'll see how it works, right? And then within this, we're gonna have other things such as Vulkan, let's say set viewport, right? We can set the viewport size, and then we can also set the scissor. Now notice how I'm not passing in any parameters on any of these functions, right? We will add parameters in the future. Right now I'm just trying to get it to a point where we can at least just have something drawn onto the screen. So I'm just sort of just paving the way forward for us, just so that we can have something visual to look at since we've been basically coding for a couple of videos now and we still don't have anything rendering on the screen, right? So I'm just sort of cheating right now, but the API should still fairly much remain the same, right? So we have the ability to set the viewport, set the scissor, and then draw. And then we're gonna need, before we can actually call this command, we need something called void Vulkan bind pipeline, right? We need to bind our pipeline first, right? And then we can basically do the draw commands and all of the other commands and so forth, right? Yeah. And then also we're gonna need another cool function called Vulkan sorry Vulkan wait idle, right? Because all these operations take time, right? And we don't want to basically close the engine whilst all of these things are still happening. So essentially this guy is going to ensure that when we basically close our engine, it waits for all the operations to finish first and then gracefully close the engine appropriately, and then basically clearing all the resources as well that needs to be cleared. Okay, so yeah, and then I think that's it, right? These are all the functions that we need. So again, let me take this guy here and then maybe put it right here. So we have list begin, then we prepare, then we begin rendering, then we set our viewport and our scissor, then we bind the pipeline, and then we draw. Okay, then after drawing we end the rendering, then we end the command buffer, and then after ending that we basically submit the frame for presentation, and then once we're done submitting, we basically just present that frame. And then from there, this one is the wait idle function that we will use outside of our rendering loop once we basically close the engine and all of that stuff, right? So this is our API, and this is the flow of things. This is how you basically render something in Vulkan, I believe, based on my own experience. So I could be wrong in the order of this, but we'll see as we go, right? I could maybe be wrong, but just take it with face value for now. Okay, so take all of these functions, and actually no, wait, hold on. Some of these needs to be booleans, right? So I think when we basically go ahead and do a frame submit and present, these two will be what are these? These two will return a boolean, right? So let's do bool for the frame submit, and then bool for the frame present, and then I might need another bool for the command list begin and end. So here as well, and then begin rendering, it's fine. Set viewport, it's fine. Bind the pipeline, that's fine. and then I'll see if I need anything else to be a boolean in the future, but I think those are the only ones I need. So copy these and then go down to your vulkan render.c file, and then way at the bottom down here, just paste those functions in here. All right, and then let's start off with the big one here, right? Frame command list begin. I am joking, it's really not that big. It's actually just one line because we're just beginning the command buffer. So all we need to do is just return wait, what? Why do I have these here? Should be like this, right? So all we need to do is just return Vulkan command buffer begin, and then we just need to pass in our command buffer, and that is stored in the context. So just do cmd buffers, and then you want the one at the current frame. Ooh, sorry about that. My mic also just dripped. I guess I scared it with the cough. Sorry, I have flu, like I mentioned in the previous video, but yeah, I can't help it, so I'm sorry. And then is single use, we'll say false for this one. And then that's it for this function, right? And then I'll do the friend down here, and then the friend down here should also just return a Vulkan command buffer end, right? And then in here it just takes in the command buffer, so we can just do context cmd buffers, and then the buffer that we want to end is the one at the current frame. So let's do current frame like so, and that's it, right? So now we have that. And then the other one that I want to do, let's just add some padding here, some spacing, just to format things nicely and make it more readable, is the frame prepare. Okay, so let's do the frame prepare. So to prepare the frame, we need to wait for our vk fences. So we need to say vk wait for fences, and then all we need to pass in here is the logical device. So let's do context logical device, and then we basically need the fence count. We only have one, and then we're gonna do context, and then we're gonna give it the fence that we want. So that one will be in-flight fences at the current frame. So we're gonna do context current frame. Okay, and then it's gonna want the wait all boolean. So let's do vk true for this. Okay, so vk true, yeah, like so. And then the timeout. Now the timeout, I'm just gonna make it a uint 64 uint 64 max. Yeah, so that will be our timeout there. And then from there we need to basically have another function here to reset those fences. So let's do reset fences, and then we're just gonna pass in the context logical device, and then the fence count is just gonna be 1 again, and then we want to basically reset the fence at the current index. So in-flight fences at the current frame, I meant. So let's do context current frame like so. Okay, and then after we've reset that, we also want to acquire the next image. So let's do vk acquire next image khr. Now this one's going to take in a couple of things. So number one, it will be our context I mean our logical device, and then the other one will be the swap chain. So we can do context swap chain dot handle, swap chain dot handle, and then it's going to want the timeout. Here I'm also going to do just a UI in 64 max for the timeout, and then it's going to want the semaphore. Now we can just obtain the semaphore from the image available semaphores, and then we want the one at the current frame as well. So let's do context current frame, and then it's gonna want what? Ooh, did I just put? Yeah, it's gonna want the fence. Do I? You know what? For this one, I just do a vk null. Okay, vk null handle for that fence, and then for the image index we can do context image. Ooh, we don't have an image index yet, so this is a good time to go to a Vulkan defines.h, and just below the in-flight fences, just add a U32, and I just call this image index like so, and back in the renderer.h, just pass in the image index like so. Okay, now what this will do, it will give us the image index of the next image, and then it will store it in the context.image index variable. Okay, because we're gonna need it later on. All right. So now once we've acquired the image along with its index, all we can do is we can do a Vulkan command buffer, where's this, reset, and then we can just pass in the command buffer that we want. So let's do context cmd buffers, and we want the command buffer at the current index, current frame, so current frame like so. All right, and then we're done. Right, so this is all we need to do to prepare the frame, and then after preparing the frame, we can actually begin rendering. So for the begin rendering, this function might be a little bit long. It's actually longer than I actually want it to be, but you'll see why it's that way. So it's not really long, but because I don't know if I really wanna, let me just think about this real quick. Okay, I guess I'll just go the long way. Yeah, I guess I'll just go the long way. But before that, let me just show you how short this function really is, though. Right, and the reason why it will be long in a second will be very apparent. So let's do context, and remember that function pointer that we stored that says begin rendering and end rendering, those two. Now we're gonna make use of them. Okay, so then all they need is a command buffer. So the command buffer that we want is in the context, so let's do cmd buffers, and then we want the one at the current frame, so we can just say context current frame like so, and then this right here, right, is the rendering info. This is what's needed because we're now making use of dynamic rendering. So with that comes a few new structs. So that one is vk rendering info, so let's do vk rendering info. Okay, then we're just gonna call this rendering info, and then this is gonna be like so, and then we can do rendering info dot s type, and then that's just gonna be a vk structure type rendering info, this one right here like so. Okay, and then we're gonna want to do flags. Let's see rendering info dot flags. Let's just set this to 0, although it's already set to 0. And then we're gonna do rendering info dot p next. I'm also gonna set this to 0. So I'll just say no. I know I'm very inconsistent with my zeros and my nulls, because in certain instances where there's a p next, I put a 0, and then I put a null vk null handle, and then I just put a null. So I'm not consistent, and I'm sorry about that. But anyway, what needs to follow from here is render area. Yeah, render area. So let's do a render area, and then let's do extent dot width, and then this we're just gonna obtain from we're just gonna obtain from the context, and it's stored in our swap chain. So let's do context swap chain, and then we have an extent in our swap chain, and then we just want the width of that. Okay, then we can duplicate this and then change this one from width to height, and then here as well, just change this from width to height, and then I think that's about it. Okay, and then all we need to do is just say rendering info. Let's do the rendering area dot render area dot offset, and then we want the x and then it's gonna be 0. duplicate that and then set the y to also be 0. And then from there, let's do rendering info dot layer count, and then let's just set that to 1. And then let's do rendering info dot what else didn't we do? View mask. For the view mask, let's just set this to 0, and then we can say rendering info dot what did I color attachments. So color, let's start with the normal one first, the color attachment count, and then we do 1 here, and then we can do rendering info dot p color attachments, and then there we can simply just say you want the color color attachment. We don't have we don't have a color attachment. Let me just see. VK rendering attachment info, VK rendering attachment info. Can I just click on this? VK rendering attachment info. So it needs an attachment info. So let's copy this. And then just paste it up here. So VK rendering attachment info, and then this will be our color attachment info. So let's do color attachment info, and then let's do yeah, so let's do it like this. Okay, color attachment info. Let's do the S type. So let's do S type VK structure type, oops, rendering attachment info, like so. And then I'm gonna do color attachment dot, let's take p next, set that to null, and then let's do let's see, what else do we have here? Color attachment, clear value. Ooh. Okay, we'll deal with the clear value in a second. Let's see what else we can do here. Image view. So image view, we do have image view. So I think that's in our swap chain dot image views. Yes. And this image views, remember now we acquired the next image when we basically prepare for rendering, right? So it gave us an image index. So the image view that we want is the one at that current index, image index. So instead of saying context current frame, what we need to say here is context image index, okay? Because we're retrieving that info from this image, okay? Hopefully that makes sense, and hopefully I'm also correct with that. Yeah, it's according to my understanding. And then from there, now that we have the image view, I think the next thing we can do is just get the image layout. Now the image layout, let's say VK image layout should just be, since it's a color attachment, we can just find the one that says color attachment, and then it will have an optimal at the end there, which is fine. And then I think the next thing should then be resolve mode, and then the resolve mode can just be VK resolve mode, I think none. Do I want to say none? Yeah, none. Yeah, none is fine. And then since we have the resolve mode, we also want to have that resolve image. So let's do color attachment info dot resolve image view. Well, I'm not resolving, so essentially we can just say VK null handle here, right? And then we can do color attachment info dot resolve layout. So since we don't have an image view, this can be undefined, so we can just say VK image layout dash undefined, like so. Okay, Yeah, and then we can do our load and store operations. So we can do color attachments dot load operation, and that one should just be let's see, what do we actually have here? Attachment load, we have up clear. Let's just take this one, up clear. And then for the color attachment dot store operation, we can essentially just do vk attachment store operation. Let's do I want to store? Yeah, let's do this one, store. Right, we clear and then we store, and it's fine. Now we can deal with the color clear. So let's do color attachment info dot clear value. This is the clear color, right? This is what we're clearing our background with. So the way that I want to do this, Vulkan has, Vulkan, let me see something. Clear value, yeah, Vulkan has this, right? This clear value struct. If my system can just find where this is defined, you'll notice that it basically is just a clear value, right? And then this clear color value essentially has your red, green, and all of that values here, your red RGB values, right? Your RGBA values. So hence the these guys here, hence these arrays here that store four variables. So what I can do, knowing that information, I can just say vk clear value, and then we can just say clear color. Okay, and then we can do this, right? I showed you what this has, right? So if I just go back to where this is defined, you notice how it has the color and then it has the depth stencil. We want to set the color, so the way I'm going to do that is I'm going to go open, then I'll open another one inside, then I'll open another one inside. Okay, and then what this is going to do is going to allow us to just set the color values that we want. Yeah, it's a little bit cryptic, but this is the way. Okay, so let's do 0.1, and then let's do 0.1 for, so this is the R channel, this is the the G, so RG, which is green. And then for the blue, we also want to have the same 0.1 value, 0.1F. Actually, no, this should be 0.01 and then 0.01. Okay, so this is RGB. So let's do A. The alpha should always be 1. Okay, then we can just close this. All right, so that's it. So this is the way I'm gonna do it. It looks weird, right? But it's simply just setting those arrays that I showed you. So again, if you just go to where this is defined, you'll notice again you have the stencil here and then you have the color. So what we're targeting is this, the VK clear color value, and then that has 4 arrays within it. Okay, and that is what we basically setting. So I'm not gonna go back there again, but yeah, just note this is what we're doing. And then we're gonna take that clear color and set it here, and that's it, right? And then we can take this color attachment info and come back and fill out the struct with it. So color attachment info, like so, and that is it. So then we can take this rendering info and put it here, because this function requires a rendering info, right? So then you just pass it that rendering info struct, like so. Okay, and this is it, right? This is all you need for this function. Yeah, this is all you need. So what I'm gonna do is, we're actually not done in this function, but I'm gonna skip what I need to do just so that I show you why we need it. And then I'm gonna go down to the viewport stuff. So the viewport stuff should be pretty easy. It's not really a lot to it. All we're doing is just setting the viewport values and what we want to render to. So Vulkan has something called VK viewport, so we're gonna make use of that, and then just call this a viewport as well, and then set everything in that struct to 0, and then we can just explicitly set those values. So viewport x, that can just be 0. dy can also be 0, and then we're gonna have viewport dot width. The width, well, let me see. I think we can just take it from the swap chain. Yeah, I think we can do that. So let's do the extent dot width. This will give us the width that we want our viewport to be, and then we can just rename this to height along with this part here. So let's do height, and then viewport has what else? It has the min and the max depth. So let's do min depth. The min depth, I guess we can just set that to 0, and then the max depth, well, let's just go with 1. Yeah, let's just go with 1. And then finally we can just call the command to set the viewport. So vk cmd set viewport, and then it's gonna want the command buffer. So we have that now, so we can just say vk cmd buffers, and we want the one at the current frame. So context current frame, and then what is the first viewport? I'm just gonna put 0 there, and then viewport count is 1, and then the viewports, oh, it's just the pointer to this viewport here that we just created. So let's just pass that in here as the address, and that's it, right? That is all we need for that. And then for the scissor, similar procedure. Okay, we're gonna have a struct to fill out, but this one is just a rect 2D, and then we're gonna call it a scissor, and then we're gonna set everything to 0. Okay, then we're gonna say scissor dot offset. Well, let's do offset first. Dot offset dot x is equals to 0. Now I'm being explicit here again, just so that I can show you that later on we're gonna add parameters here which will then populate these values. Right now we're just hard coding stuff, right? So scissor dot extent, and then we can do context. Then we can get this from the subchain as well, and then we can just do subchain extent like so. And then once we're done with this, we can just simply say vk cmd set scissors. Okay, and then all we need to pass in is the command buffer. So let's do cmd buffers, and we want the one at the current frame. We want the one at the current frame, and then the first scissor, I guess we can just set 0 for that as well, and then 1 for the scissor count, and then the scissor pointer is just the scissor we just created. Okay, and that's it. All right, so now we're done with these two functions. Now we need to do the bind pipeline. Now actually this one's going to require a little bit more setup, so I'm going to skip it for now. Then we can do the Vulkan drawer. The Vulkan drawer is pretty simple for now. At least it will get a little bit kind of long-ish, but not too complicated, right? But for now it will be very simple. And I think the way that I'm gonna do that is I'm gonna do VK CMD, because we don't have indices and vertex buffers yet. I'm gonna hard code some of these things. So I'm gonna do draw, and then it's gonna want the command buffer. So let's do CMD buffers, and I think it's also gonna take in the one at the current frame, and then it's going to want the vertex count. So again, we do not have vertex buffers and index buffers and all of that, so I'm going to hard code the value 6 because we're going to draw a quad, and a quad has 6 vertices. Okay, and then the instance count is 1, and then the first vertex 0, and the first instance 0. Okay, and that's all our function, our draw call is going to do, right? Our draw command is going to do. Yeah, and then because we have begin rendering, which is this long guy, he's gonna now need a friend here called end rendering, and he's gonna be fairly short as well. It's basically just gonna be like maybe just one line. But you'll see later on why it's not really gonna be one line. But yeah, right, so we're gonna make use of, let's see, this same function pointer. This one is begin, but there's one called end. So let's do context end rendering khr, and then this should just take in the command buffer. So let's do context / cmd buffers, and we want the one at the context / current frame. Okay, and this is essentially all we need, but I'm gonna extend this function in a bit. You'll see. So I think this just wants the address of that. Vulkan command buffer, and yeah, okay. Let me double check that. Yes, okay. Then we have frame submit. So we need to finally submit. So the way that I'm going to do this is also fairly simple. So we're going to have a vk submit info struct. So vk submit info struct. So we're going to call this submit info, and we're going to set this to 0. And then we're going to do a submit info.s type, and that was just going to be a vk structure type submit info, and then we're gonna have, I think it was vk pipe line stage flags like this, and then this will be our wait stages. This will be an array, and it'll just hold one stage for now at least, and then that will just be a vk pipe line, and then I have to say stage color attachment. I think it's the first one, right? Yeah, this one. And then all we need to do now is basically fill out the submit info struct. Okay, so I'm gonna do submit info, and then I'm gonna do the wait semaphores. We only have one. Then I'm gonna do submit info.p wait semaphores. P wait semaphores, and then this is just going to be at the address of the context image available semaphores, and we're going to want the one at the current frame. So context we want the one at the current frame, so current frame like so. Okay, and then once we have that, we're going to do submit info, and I think we can do this one, p wait stage, and then this is just what we just added here. So we're just gonna pass in those here, and then we can do submit info dot, and then command buffer count. We can just set this to 1, and then we're just gonna give it the command buffer. So we're gonna be p command buffers, and then that should just be at context cmd buffers, and then we're going to pass in the one at the current frame. So let's do context current frame like so, and then let's see, what else do we need? Submit info dot I think signal semaphore count. Yeah, I think we need this. We're only gonna have one, and the p signal semaphores, these will be the queue complete semaphores. So we will just do context queue complete semaphores, and then these are signal semaphores, and then we're gonna do context the one at the current frame. Okay, and then I think, let me just see, submit dot, yeah, that's it. Yeah, I think we have all of them, well, the ones that we need. And then we can do vk result. I'm gonna just say result is equals to vkq, right? We need to submit this. vkq submit I want this one. And then what I want to do is just pass in the Q. So context Q, and then it's gonna want the submit count. We only submitting one. And then it's gonna want the submit info, and then it's gonna want the fence. So for the fence, we can just give it the in-flight fences at the current frame. So context slash current frame. Okay, and I misspelled result. Okay, next we just need to do that sanity check situationship. So let's just do if result is not equals to vk, vk success. We can do something like L error, and then we can just bleed about it, you know. So we can just say failed to submit frame. Okay, let's just say Vulkan frame or something, I don't know. And then we can return false here. Otherwise we return true. Okay, sweet stuff. So after submitting, we need to present. So let's also set up that struct. So it's also going to be fairly similar to this, right? In fact, let me just already copy this because I do know I'm going to need this. So just paste it there at the bottom, and instead of Q submit, we presenting, so we need to say Q present. All right, so Q present KHR, and then we pass in the Q, and then we pass in the present info. So it doesn't want fences, so it just wants the present info. So for that, we can just say VK present info KHR, and I'm gonna say present info equals to 0, and then what we can do is fill out the struct real quick. So S type is just gonna be VK structure type. Let's see, VK present info, so present info KHR. And then present info, let's do wait semaphore count. I'm gonna set that to 1. Let's do present info.p. Nope, p wait semaphores. I think we can just make use of I think it's the Q complete semaphores, right? Yeah, and then we can just do context current frame. So we want the one at the current frame, and then present info dot let's do subchain, and then we're gonna do one subchain, then present info dot p subchains. That is just gonna be one subchain again. So let's do subchain dot handle. So that is the subchain that we're gonna be making use of, and this basically takes in the address of that. So p subchains, then it's gonna want the, let's see, p subchains, p image indices. I guess we can take this as well. The image indices, it's a URN32. In this image indice presenting, oh, okay, yeah. All right. If you go all the way back up where we prepared for the frame, we got this image index, right? So that's our image indices. So down here, just pass in that essentially, right? I think so. We can do context image index. All right. Yeah, and then we can do what's left, p results, and then we can just set this to 0. It's fine. Yeah, and we can feed this function the present info we just created, and we can just pass that as an address, I guess. And then failed to present Vulkan frame. Okay, and this function is not done. What we need to do now is increment this current frame that we keep using or keep referencing throughout our application, right? Throughout our renderer here. As you guys can see, we're using it here, but we're never really changing it. It's always at 0. So right now, every time we present, we need to increment it, right? And make it loop, right, as well. So we're gonna increment and loop the index, okay? The frame index, I guess, right? So with that, we can do context current frame equals to context current frame, and I'm gonna add 1 to this. Then we're gonna do a modulus, and then we're gonna basically do context swap chain dot max frames in flight. So we're gonna divide this by the max frames in flight, I guess. Okay. Yeah, this is a modulus, by the way, not a division. So yeah, I think that's it, right? Oh, we can just do this function here. So this function is fairly simple. It's just vk wait idle. I guess we can take the device wait idle and then just say context logical device. Okay, that's it. That's literally it. And then with this said, I think we've basically done all the functions we need. Let me just quickly check. Oh, we have this one here. I'm gonna put a to do here, just so I don't miss it. And then everything else is done and dusted. Okay, cool. So the one that we need here is the binding the pipeline. So this one is a little bit, it's not complicated really, I think. So how do I want to do it? We need to bind the graphics pipeline. So let me just quickly go to the graphics pipeline header file here. We don't have a function to bind. Yeah, we don't. So let's just go to the Vulkan pipeline.h, and then down here just add a void, and then just call this Vulkan graphics Vulkan graphics pipeline bind. Okay, this is the function we're going to use to bind the pipeline. So what do I need to bind the pipeline? Let's do vk cmd bind. Is it cmd? Wait, how do we bind the pipeline again? Cmd bind pipe. Yeah, it's just this. And what does it take? Okay, this won't give me the IntelliSense in the header file for some reason. So let's just put this in here. And let's see what this takes in. Nothing. VK bind pipeline. Is this even? It takes in a command buffer, a pipeline bind point, and the pipeline. So I'm just gonna copy this and delete this. Okay, then back in the header file here, I'm going to paste that stuff that I copied over. So we're gonna take in, it's gonna take in the VK command buffer, right? This is our command buffer. Then it's gonna take in the VK bind pipeline point, pipeline bind point. Okay, and then it's gonna take in the VK pipeline. Now we already have a struct that encapsulates this, so let's just do pipeline instead, like so. Okay. And I think that's it, right? But unfortunately, for us, this is not our naming style. So let's do cmd buffer. And I think I should make this a pointer. So let's make a data pointer. And then for the VK bind point, this is just an enum, right? So this is just an enum. And we're going to make use of these two but for now we only have graphics, so we don't have compute shaders and stuff. So this is the one we're going to use pretty much most of the time. Yeah, so that's just an enum. And then the pipeline, I guess the pipeline we can take a pointer, so yeah, we can just take a pointer there. Okay, save this, copy this function, and then go down to the pipeline.c and then paste it down here and then implement it. And again, it's a fairly simple function, so let's do cmd pipeline bind pipeline like this. And all you need to do essentially is just pass in your cmd buffer and then your bind point. Oh, let's just rename this to bind point. I think that's better naming, right? Yeah, bind point. And then you're gonna need to do pipeline here as well. So pipeline, and remember it wants the handle, so like so. What's this current about? Oh, let's just dereference this. Yeah, and then since I changed this name here, let's just also change it in the signature. So perfect. Just make sure you save all your files and then come back into the renderer.c, and then here where I put that to do is where we're just gonna call that function. Yeah, so let's do Vulkan pipeline bind. Let's do bind pipeline, and then for some weird reason I am not getting IntelliSense. Yeah, I am. Oh wait, we don't. VK command buffer. Yeah, I'm not getting IntelliSense, but I don't know why. Okay, let's just do context command buffers, and my command buffers is a VK command buffer, yes. And then we can just do the one at the current index. So let's do context current frame, and then I really don't know why this is not giving me IntelliSense, but VK bind point, we want the graphics like I said, and then I think the last one was just the pipeline. So let's do context pipe, graphics pipeline, like so. Expected 0. Oh. I'm calling this when I'm supposed to be calling this, so that's why the IntelliSense wasn't working. Oh, my bad. Okay, right, okay, my bad again. And then here it wants the VK pipeline, so passing pipeline, take the address. Okay, so hopefully I did everything correctly, otherwise I am dead. I'm sorry, I'm joking, but hopefully we have everything set up properly. So what we want to now do is take all of this, copy this API, and go down to the renderer.h, okay, and then paste it in here, and then just do a multi-select, and then remove the word Vulkan and replace it with renderer, okay? And then take all these functions again, copy them, come back into the renderer.c implementation file, paste them in here, and then all we need to do is just link these functions with those functions found in the Vulkan renderer, okay? And this should be fairly simple. So for the command list, just say Vulkan command list begin. For the frame prepare, just say Vulkan frame prepare. Okay, and this returns a boolean, so just do return. And then for the begin rendering, just say Vulkan begin rendering. And then for the set viewport, just say Vulkan set viewport. And then for the scissor, you get digits, right? So Vulkan set scissor. Okay, and then bind pipeline, just do Vulkan bind pipeline, and then this one Vulkan drawer, and then this one Vulkan end rendering, and then this one Vulkan frame list end, then Vulkan frame prepare, okay, and then Vulkan frame present, and then Vulkan wait idle. Okay, sweet. Then just copy again all of these. Then go down to your main.c, and then in your loop just paste all of that in here and just get rid of these. Okay, and just move the render idle outside of that and put this in here. So what's happening here? So we're beginning our command buffer, then we prepare the frame. I think we might have to do this before preparing the frame. I might have to do that, I guess. I think, right? I'm not sure, but I think, because, well, let's see, we begin the command buffer, then we're gonna need to, I think the prepare frame actually comes before all of this, or does it? I'm not sure. But then we begin, we begin the command, then we can begin the rendering, then we can set the viewport and the scissors and bind, and then call the draw commands, and then after that we can end the rendering and then end the command buffer, and then from there we essentially just submit the stuff that are inside that command buffer and then present. Make sense? Hopefully it makes sense, right? So let's try and build this. I'm expecting a couple of errors. Oh, well, I still only have warnings, but okay, let's see. Nothing. Nothing. So for the given vertex buffer binding, vertex attributes description. Oh, okay. Let's go quickly back to the pipeline.c, all the way up here where we set the vertex descriptions and the pipeline vertex input. This, right? Just copy this and comment it out. Okay. Yeah, just copy it. Copy this, comment it out, and then paste it again, and then just set everything here to 0 because we don't have vertex and index buffers yet. Okay, so this is temporarily placed here, and then I'll just do a fix me, remove once we have our vertex buffers. Okay, then I'm gonna save this, then I'm gonna try and rebuild this and see what it gives me. Hopefully that should kind of clear that message. It kind of worked a bit, I guess. And then p create infos, p vertex input state attributes does not have a location. Wait, huh? Clear this, run this again. Okay, let's see. P vertex input state, vertex attribute description does not have a location 0. Created with the vertex input state, and let me take a look at my shader. Okay, yeah, I remember I actually just put this off stream before starting this video, so I think let's comment this part out and you guys can just paste this code in. This code is just what's gonna draw our quad. So save this shader, try and run the app again so that doesn't crash. Right, so that doesn't crash. So the shader code is fine now. So just copy this real quick, screenshot it, pause the video, whatever you gotta do, and then I'm gonna try and run this again and try and figure out what exactly is happening here, because I'm not getting any info on my end. So what I'm going to do is come back here and see the order of operations again. So I'm saying frame prepare, command let's begin rendering, then set the viewport, set the scissors, then we bind the pipeline, then we draw. Okay, then we end the rendering, then we end the frame command list, and then after ending that, we submit, and then we present. So that's correct. That's literally correct. So let's quickly go. Wait, let me see. Let's just double check here. Vulkan frame prepare, Vulkan begin rendering, set viewport, set scissor, bind, draw, end rendering, free command list end, frame submit, and here I said prepare. So this should be submit, and then present should be present, and then idle should be idle. So let's rebuild this again. That was my own typo mistake there. And then ladies and gentlemen, would you look at that? Oh man, this brings me so much joy. Oh my days, man, this brings me so much joy. We finally have a quad drawn to the screen. Oh man, but we have a bunch of errors which we're gonna talk about right now. So this is what comes with, I think it comes with dynamic rendering. I am not sure if this was applicable without dynamic rendering, but yeah, this is something that we need to do, right? It's talking about how the image needs to be, you know, changed to a specific layout and then changed back into a specific layout. Like for example here, the image VK present layout, or the VK present shared present KHR or whatever, right? So this has to do with the images, right? So the images need to be in a specific layout. So images passed to present must be in layout VK present source KHR or VK layout shared present KHR, but is in the VK image layout undefined. So currently our images are undefined. So we need to add that functionality. So back into the renderer.c, what we need to do is when we begin rendering, right? This needs to happen before we begin rendering and after we begin rendering. So we have end rendering here, but I want begin rendering, right? So this function is about to get a little bit longer. Well, it doesn't really have to. I can actually separate what I'm about to code into its own function, and which I actually will in the future. But I think for now I'm just gonna do it in here. So yeah, I think for now I'm just gonna do it in here. Okay, so what we need to do is basically transform our image from VK undefined into something that Vulkan wants when we are ready to present, right? So what I need to then do is we need to create what is called an image memory barrier. Okay, so you can do VK image memory barrier, oopsie, barrier like this. Then this is going to be a list or an array of image barriers, okay, and it's going to be well, let's allocate. So let's just cast it to this. So just paste that in there, just put a pointer there, so we're casting it. So let's do malloc, malloc, and then we just allocate memory for this array. So let's do size of, I could use my own array container though. It's fine. Let's just get the size of the image, this, and then we can do array get count of the context slash subtrain dot images. So we have a list of images, so we just want the count of those images to create the image barriers, right, for those images. So once we have the container, the list or the array, of image variables, we need to basically loop through them. So let's do an int I equals to 0, and then I is less than array get count of context slash swap chain dot images. Right, then we're just gonna basically increment this, so I plus, and then what we're gonna do is we're gonna get image barriers. We're gonna get the one at the current index, and then we're gonna set the s type to vk structure type. I don't know why I keep pressing on the wrong keys. VK structure type, VK image memory, image memory barrier. Okay, that's the structure type that we need. So now there's a lot of stuff that we're gonna need to fill out here. Damn. Okay. Various I dot. Let's do the p next. Let's just set that to null. Oops. And then let's do image barriers I dot. Let's do the source. Source access mask. Let's see. VK access mask. No. Access memory. Yeah, this right here. Access memory read or write. I think it was right. Okay, and then we're gonna have, that's the source. Then we're gonna have destination. So destination essentially should have we're writing, so then we should read what we wrote, right? I'm just trying to make this make sense to me. Okay, so yeah. And then I'm gonna have old layout, and then the old layout, right? In this error it says that our layout is currently undefined, so we're just gonna take this VK image undefined. So this is the current layout that we're at, right? And we want to essentially transition to a new layout that Vulkan is happy about. So that will be the new layout, and then that new layout, just fix that typo there. That new layout should be, I don't know if they have it in here. Well, because I don't want to use VK layout shared, I don't want to use that. Layout present. What do we have? Let me see. VK image layout. Because right now I only have a color attachment stuff, so yeah, I think I'll go with this. Color attachment optimal. Yeah, okay. And then that will be a new layout. Then I can say image barriers I dot what else do I need to do? I have the new layout. Let's do the source Q family index. That should just be key index is at 0, so yeah. And then I think we also need to do the destination Q index, and that should also just be 0. Sweet. And then the image barriers, we're almost done here, and I think the one that we need next is probably this image. And then the image, essentially, if you think about it, we already have these images, right? Those are in our subchain, so we can do context subchain dot images, and we want the one at the current index of this loop, like so. And then let's see what else we have here. I dot, what else haven't I done? I think it's just the sub resources. So I'm going to do aspect mask, VK image aspect, depth, metadata, stencil. Well, we just have color, so do they? Yeah, let's take the color, VK image aspect color. Yeah, and then I'm just gonna double copy this a couple of times. Then I'm gonna do a multi-select and do this, okay? Because the rest of these things fall under the sub range. So let's do base map level. That will be 0. Then let's do level count. That should be 1. And then what else did we have? We have base array layer. 0. Let's just say 0. And then layer count. Layer count, we only have 1. Okay. Alright, so I think this is fairly it. Okay. Then what we need to do is just say VK CMD bind pipeline barrier. Not 2. And then, wow, this is a lot of stuff, man. Wow, Vulkan. I hate Vulkan, but anyway, let's go ahead and pull this huge parameter list. So it wants the CMD buffers, so we're gonna take the one at the current frame. So context current frame, and then it's gonna want the source stage mask. Here's where I always get confused with these things, because I never know which one is right and which one is wrong. But I'm just gonna use the ones that I used in my previous engine that I still remember. So those are gonna be commands. I think it was the commands bit, and then destination stage flags bit. We're gonna do VK pipeline. Am I even spelling that right? Pipeline stage, and I'm gonna go with all commands again, I guess, right? Yeah, because I don't know. I really do not know. So yeah, I'm just gonna pass in zeros for these, and then memory barriers. No, buffer memory barrier count. I'm gonna say 0. P buffer memory layers. Pointer slash say no. UI in32 barrier count. Well, the barrier count should essentially be equal to the amount of images we have. So let's just do get array size. So array get count. Not array size, but get count of the images that we have in our subchain. So that will be context subchain dot images. Okay, that should give us the count of the array. The count of images that we have in our subchain. And then the barriers themselves. So this will be the image barriers we just created. Okay, these guys up here. Okay, save, and then because this right here we allocated, I think I'm just gonna free it right here. Okay, just so that we don't have that memory leaking out. So I think that's fine, and then that's it, right? So right now we basically transitioned the image from undefined to this color optimal attachment type of situationship here, I guess. Yeah, now we're not done, because if I build this, right, it might get rid of half the errors maybe, or none at all. So let's just see. Okay, so it still works, but you notice how we still have those errors again. So if you look at them again, it's gonna say images must be in layout VK layout present source character or VK layout shared, but is in VK layout color attachment optimal. We've literally just transformed it from undefined to color optimal. But after rendering or presenting or whatever, right? We need to retransform or retransition these images to another layout again. So right after, I'm just gonna copy this whole thing. Right after end rendering, right? So let's find end rendering, right, which is right here. So I'm gonna paste this right below that. Okay, and then we're gonna transform this image into what Vulkan wants. Okay, so again, this is where I'm confused. This is the part whereby I really don't understand this concept too well, and I'm relying on my past experience just to get it working. You guys can do your own research and figure out how this truly works. So I myself, I'm also just as confused as you. But anyway, let's get it working. So the source access mask needs to change from right bit to, let's just remove this because we have a color attachment, so this will have to be color attachment right bit. Okay, and then here destination, we can just say VK access memory read bit, but we can also add another one here. Wait, why isn't, oh, there we go. We can also add another one here called VK access memory right bit. Okay, and then the old layout is the layout that we transformed to, which is the optimal here. So we just paste this in here, and then since Vulkan says it wants it in present.khr, I'm just gonna copy this here, and this will be the new layout. Okay, just paste that in there like so. So VK image layout. I'm not sure about shared. Let's just do VK image layout present source khr. Okay, and then 0 0, and then I think everything else is still the same. And then down here we can change this to, I don't know, let me leave it this way. Let's just experiment. Let's see. Okay, let's just see. Let's experiment. Let's see. It works. So we close that, and oh wait, are these from, oh no, that's from the old build. So let's just clear this and rerun it again. Yeah, so we don't have any reds anymore, so it means everything else is working. So that's it, ladies and gentlemen. Now you could argue that I could take this whole thing and just put it in its own function. Matter of fact, I will, but not in this video because this video is not long. So yeah, so this is where I'm gonna end it. We have finally managed to get something drawn to the screen, but before I actually go, I want to show you something, right? So that the engine is working, it's running. So if I just do this, notice I'm gonna just trigger a screen resize. Okay, just watch the console right here, just watch it. Right, I'm gonna trigger screen resize. Notice now we have errors. Okay, now what are these errors? Okay, so if we go ahead and read this, it's gonna say failed to present Vulkan frame, right? That's because we've just resized our screen. Now our images, they just got invalidated because now the sizes and everything doesn't match up with the window, right? So we need to basically add support for screen resizing so that our image has the correct dimensions each time we basically resize and so forth. Although it looks like it's stretching with the viewport and everything, but it's still not technically correct. Okay, so that's what we're gonna fix in a later video. So yeah, I'll see you guys in the next one. If you enjoyed today's episode, hit the like and subscribe button, and I'll see you guys soon. Cheers.